start the next recording. All right, so let's go over. Let me see. That's the document. That's lab 2. Here is the lab document. So one of the things that you're going to be working with next, we're going to be working with is this basic framework package. We're going to go over that this week. Let me just bring up the lab 2 document. So cars, planes, and polymorphism. So you really do need to read this lab before starting. It's the lab, right, is a loose write-up of required code elements. Not everything covers specification, and there's also so it's your responsibility to find the holes and implement them. And if you can implement something better than written below, try it. The next piece that this lab has, so this piece basically the written work. Several pages from, I've given you lots of documentation. Those of you who've gone through the Unreal Engine course, this is going to be really easy. It's going to be very familiar. Several pages from the Unreal document given to you. Read them, particularly is the framework. Provide a diagram that shows the basic of the core gameplay framework classes in Unreal Engine.
This we probably have to create ourselves.
No, you don't have to create yourself.
Oh, it'll probably already be in there?
Zoom all the way. Where is it? Where's the image? Here is this is the new version of it. Come on, you've seen this image before. I know those of you took understanding the basics. Browser, customizing project levels, components. They actually have a Unity Unreal Development Overview page. Where is that image? Have they replaced it? But there's an image of basically of the controller class, inheriting the pawn, and you've seen this before. Let's go back to the document. I want you to think about Unreal's actors functionality in Mono. What are the core features that are missing in the Mono behavior class? It's an actor. It's a complete class. The other thing is that in Unreal that actors can take damage. If you were to implement pawn controller, player controller as scripts in Unity, what are the most important pieces of these classes you needed? Controller is the base class. Player controller is an implementation of controller. And then controllers take control of pawns. What essentially you need for possession by the controller classes, you need functions. You need a variable to hold the pawn, and you need functions to control it. We're going to go over that. You do the range, you'll just find the answer you need. Again, there's an answer. Let's talk about system diagrams. This is the next part. I want you to diagram there's a couple game types below. Express each game mode as an extension and inheritance of the previous one. You should have an image document for each game type. Use ULM diagram tool to help build with this. All right, what is UML? It's a universal, it's like a universal module language. Basically, the idea is that we can actually do this in draw.io. Create a new diagram. We'll do a blank diagram. So where is it? Process, rectangle, here we go. Here's a list. And you can, you can keep adding things to the list. So the idea here is that you can express things as, hey, I've added, so again, like level 1, go back to what you know, level 1, this would have basically the method 1. So void method 1. And then level 2, we would just copy and paste this. I'm going to jump in here and put we inherited method 1, and then we've added void method. So this is the idea behind that. Basically, you're listing out all the the properties and the variables are listed out. So it's basically basically, again, this would be level 2. Inherits level. All right. Well, let's go back to the document. So the idea here is that simplify your diagram where you can collect things into categories. So you don't need to list all the weapons. A weapon class to abstract all of them is what you would want. Player model would be a player pawn. The player and the player pawn are two different things in this model. All right. Remember, the player itself is represented by its player controller in Unreal Engine, and we're going to stay with that. And the player controller takes control of a pawn. So we're going to do deathmatch. And I'm just going to bring up... I'm going to just do this in Notepad. We can do this quickly. So deathmatch. All right, what do we need for deathmatch? Jacob.
Well,
one thing.
Players. I'm gonna
players, which will be represented by the player controller.
I'm sorry.
What's next? Morgan.
Health?
No, that's we're going to abstract that. So there's two ways we're going to abstract. The first will be the player pawn, which will health. This has health. I'm going to go right ahead. I'm going to go because player pawns have weapons. All right, there are pickups. This is armor, health, power-ups.
Stages?
We're not going to use the term stage. We're going to use basically levels. So stages, zones. So it's the gameplay space. All right. Players, bonds, weapons, pickups. And there's one more thing that we need to include. And that's going to be our game rules. We'll specifically for deathmatch. We can expand upon this. All right. Actually, one of the things that we'll want to have in this list right here do this after pickups. Player starts. Now I'm adding this in here because this is going to be important for team deathmatch. So the two things that we need here is basically game rules for team deathmatch, and we will want to have player starts, team player starts for teams. This moves on to, again, we'll do capture the flag. We now need to make sure that player pawns support holding a flag. The CTF flags. CTF actually be the flag base. And then this would be the CTF capture zone. All right. We've broken down the CTF component in 3 different ways. So we have got the flags. When you pick up your flag for your team, you can teleport it back to your base. So the base is where the flag starts. Where you capture the flag does not necessarily mean that it's the same place as the flag base. So I've actually built a map where the enemy team spawns in your base, you pick it up and you try to run it across the other side and plant it in their base to score. So the cap zone, where you bring the flag to, we're going to set this as a separate piece as to the flag base, the flag itself. And then finally, there are some game rules for CTF. And I want you to think about this. We're now getting down to how is our game work? What is our essential pieces? Again, deathmatch is the biggest right here because it's setting up a lot of different things. Like team deathmatch inherits from deathmatch. CTF inherits from team deathmatch. And I'm gonna deathmatch, team deathmatch. I want you to see how these game modes are laying upon each other. We can go look at the finals, and each of the game modes in the finals. We can look at. We could probably look at if I played Marbles Out Loud, I'd be able to tell you more about it in terms of game design in that respect. But we can go off in different directions. There is different modes in particularly Unreal Tournament. There are different modes. There was Bombing Run, where there's where there are basically score zones. It's basically football with guns. You can toss the ball in for 3 points, or you can jump in and kill yourself for 7 points. Go figure. There is assault. There was vehicle assault. There is vehicle capture flag. There is I think double domination. So basically, there's two points on the map that you have to dominate and control to win the map. And it goes and the types of maps that Unreal Tournament had at one point went on and got bigger and crazier, particularly when you added all the mod stuff that went on. But your game is a system. All right, we're looking at, I know in modern game design, there are 2 components that we have to be concerned about. It's the game, the experience is one piece, but right now we're focusing on the more fundamental pieces, the game as a system. How does it work? Why does it work? What are the rules? So there are game modes of the diagram. I've actually gone through all of these. But there's the game application of the diagram. I'm going to do Skyrim right here, right now. I'm going to start with from the launcher. So let's go to Draw.io. I'll just throw this all out. Launcher. Game start. And I'm just going to basically, I'm going to throw a small box up here is mod setup. And it's basically, I'm going to create an arrow right to it. An arrow right back. And then from the launcher, it is main menu. And from the main menu, there's a couple ways we can go. And this is all going to lead to a zone we're going to call gameplay. So one of them is here is from the main menu. It is going to be text. There we go. New game. There is going to be another way in. Load game. We know that there is an options menu. And I'm going to go, let me grab. Oh, there we go. We know that gameplay is going to go up here and it's just going to come back. So it goes back and forth. And there's things here in options like load game is going to show up there as well. Question.
For the game applications, you're just looking for like the UI components mainly?
No, we're looking like application flow. We're talking about,
Okay.
yeah, talking about this is the structure of the application.
Okay, got it.
So one of the things that's interesting about gameplay is that we have and I'm going to refer to as zone load just to, and this is going to come right back. So again, new game it actually should be going. Actually, let me bring this down. Like new game, load game, actually going to be going to load zone. But basically, the idea is like, hey, you went into a dungeon. Skyrim loads a new area. So there's two ways to look at game. So there's two ways with Skyrim. Basically, this is you roaming around the gameplay space, and there's two types of zones. There is the overworld where it's cells, and it's basically unloading and loading cells as you move around. Skyrim does this. Fallout does this. Starfield sort of does this. But the idea is that you go from an overworld zone to another subzone. And that basically basically load zone comes right back to gameplay. Cutscene, it's part of gameplay. The start of the game, part of gameplay. You loaded a game, part of gameplay. You saved the game, that, option menu, save game menu. And this is Skyrim in a nutshell. This is the game, like the gameplay loop is here. I mean, yeah, there could be things. There's things such as level up. In fact, I'm gonna delete these. Put these arrows in. In fact, these, I'm gonna pull these up. So new game and load game, we're going to load the zone and they're going to go into gameplay. But so we can load game and new game. New game has a specific zone you're going to load to, and it's going to set things up for the game. Load game is going to basically like, oh, here you are, your stats, your stuff. I mean, like there's level up stuff. There's like inventory. And these are, again, like particularly inventory, I think these are kind of like panels. Certain extent. Shopkeeper. Dialogues. So you're going back and out from gameplay for particular purposes, like inventory. Go use this a healing potion. I'm gonna throw, for sake of argument right now, your magic stuff, the magic throoms, all gonna fall under inventory. But like the shopkeeper, that's a panel, the dialogue panel you have with NPCs. I mean, I should probably split those two up, but basically, they're kind of embedded in gameplay, but I'm just bounce in and out because they're different panels, different stuff. And this is one of the things that I'm trying to get across to is this idea of abstraction, is that you can boil down things to its root pieces and look at it in terms of gameplay. The term that we want to get across right now and I need to make the idea is, what is the minimal viable product that you have to have? And that's what, going back to looking at deathmatch, what do we need to have a deathmatch? We need player controllers. Okay, we need the player pawns. All right, we need at least one character for them to run around and shoot, to be targets. We need weapons for them to shoot at. We need at least some sort, we need example of armor, example of health, example of a power-up. We need player starts. We need to know where they spawn in the world. We need a level for them to play in. And we need rules. And this is basically, hey, how many... And rules in this case is, hey, how many kills do we need before I move to the next map? How long are we going to play before the next map in case it's like a slog? Idea weapons, things that come from weapons. We get into the idea there's also damage types. Is something that we can start talking about. This weapon does fire. This weapon does lightning. This weapon does bricks to your damn face. We can look at like weapons such as like the gravity gun from Half-Life 2, picking up objects and throwing physical objects at people in the world. Weapons, we can also, in extension, on weapons, projectiles. By extension. Now, health, armor, ammo. These are pickups. So we're separating these out because essentially what you're doing with pickups, you're saying in this world, an item can spawn here. Particularly on Unreal, they have a pickup base. And that base spawns the object into the world. And when that gets picked up, it tells its base, hey, I've been picked up. And it sets a timer for it to respawn in the world. If that's how the rules are. So, again, I want you to think about, again, we can go in, we can start detailing things out in different ways. I mean, we can go with, there's capture the flag. There's also, I know Team Fortress has an assault mode where you're capturing points. Capture this point, you move on to the next. They have a mode where you're capturing points, and that you get points, and that the gameplay based on who's controlling what points. Battlefield has a flag system and ticks. As you capture points, you effectively roll down control of a point and roll up control on a point in Battlefield. And if you're controlling more points, the other then more like your majority of the map, then the other team is taking penalties on their ticks, which is how you respond. Stuff responds. Players respond. Items respond. And that brings a map like where both teams start with 200. If one side starts dominating the other, that's dominating by kills, but it's also by control. Then that number of ticks start dropping faster. And when that hits zero, you have lost. The other team has won. So, one of the things that you might end up doing is building a analog version, or an analog version in like desktop tabletop simulator, for example. This is great to get ideas down, get mechanics down, and how things should work. One of my best projects was a multiplayer game, and we sat down on tabletop simulator and we planned out how the mechanics should be working. How, like, this player is this role and this player is that role, and how do they work together? How do they interact with each other? Are they in opposition to each other? How does some of the movement mechanics work? There's things that player of X role can do, but player with a Y role can't do. This is the application development, the application programming side of the degree that we're trying to get across. And I am going to go through. I want you to think about Tetris. How is Tetris structured? Tetris is going to be simple. Same with Super Mario Brothers. Think about Super Mario Brothers, either 1 or 3 on the NES. Super Mario Brothers 2 is a different game. It's not structured the same as Mario 1 or 2. Super Mario World on the Super NES is structured the same. It's structured like 3 and the levels are more structured like one. I'm trying to think. Yeah, I want to think of. Yeah, I want you to think about rules about structure, how the game is played, what you're doing, how you're doing it. What are the mechanics? Knowing, and that's the big thing, is that you are building the mechanics of your games, and that's the foundation for the experience that your game is going to have. I mean, we can go talk about the finals. Finals is an Unreal Engine game. It has the hallmarks. It is off the the tree of Unreal Tournament in terms of deathmatch and team deathmatch. What makes the finals interesting? Like, you've got quick cash out, and the idea there are basically in the mechanics of the game is there are points in the map where loot boxes, essentially, not cash boxes, I should call them, not loot boxes. Cash boxes can spawn. You have to go and hit an object, and it will spawn a box into the world, and then you got to take that box to a cash machine, and then you got to hold the cash machine until the time runs out. But the cash machine can be captured by other teams. First team to get two of these cash outs pretty much wins the game. And they basically, each of these boxes is about like 10,000 whatever money they're using in game. And so the first team to 20,000 wins the match. But there are other where killing. There's another mode where you go around and you get coins, and you put coins in the machine for your team to get money, and the first team to get a certain amount of money or when time's out, the team that had the most money wins that match. And those are the basic mechanics. And then you get into where the finals gets weird. There's lots of customization for your characters. I run around in a black one of my characters that I have set up, I think one of my heavy character, runs around in a black tutu with wings, with a sledgehammer, which is shaped as a guitar. And I have an RPG and mines, and that's one of my wrecking crew. I call it my wrecking crew setup. I have another one where I have a character who is in a boxing outfit, and he's got the sneaky hide, go invisible modes. I'm trying to think what else. Before I had the black tutu, I have I refer to him as the captain because he's got a captain's hat, but he's got bully face paint and a Elvis jumpsuit. There's a weapon in literally, and we can get now into weapons. We already brought out the sledgehammer can be look like a guitar. They've got another version of the guitar now in game with the current season, but it could be a bamboo pole is one of the versions. The MP pea shooter, literally one of the versions has a little receipt printer on the side of it, and when you kill people, it prints out a receipt for your kill. And this is the stupid stuff that the finals does. Not as it was popular last year. It's not popular now. People have kind of moved on to other games. But we can talk about again. We're talking about deathmatch, and we're talking about team deathmatch. We're talking about capture flag. We can talk about cooperative mode. We can talk about Helldivers 2. I mean, that's a cooperative game. And it's purely cooperative. And the CEO is basically like, yeah, if you want to play something competitive, here's another game to play, because they're focusing on just that competitive aspect of the game. Sorry, the cooperative aspect of the game. It's so cooperative. Basically, there are as you run on the map, there are these samples. They're scientific samples that you pick up. They're for you to run around the map and find them on the map. And when you pick them up, at the end of the map, if you extract with those samples, the whole team gets those samples. So it's not just I picked them up and they're mine. No, the whole team gets credit for those samples. Another thing is that they credit kills. Like if someone, and this happened to me last night. I forgot that there was a weapon that I wanted to use because I had a personal objective for that night to use X number of kills with that weapon. I managed to use to pick the wrong weapon when I came into the map. But I completed the objective because someone else got those kills for me with that weapon. These are game. These is what, again, getting back to the thing I want you to make sure where we're going with this is that modern game design consists of two things. It is basically the rules and the systems that you are creating, how you're going to play, and it is the experience from playing it. I'm going to bring up a paper. It's an older paper. MDA game design. It's called the MDA framework, and it stands for Mechanics, Dynamics, Aesthetics. And the paper, and this is the thing that's about the MDA framework that you guys need to understand. It's old. It's it's a couple decades old now. And the problem, and this, they have a great image right here. So, as a developer, you look from the mechanics to the dynamics to the aesthetics, and the player sees the game from the aesthetics, dynamics, mechanics, and that's the perspectives version, and that's true. But what's really going on is that that's just as a perspective view. But ultimately, the MDA is actually a triangle. All right. If you affect the aesthetics, it can affect the dynamics and it can affect the mechanics. All right. A good example is I give you a skin that's brightly colored. That's going to affect the that's a mechanic. Right. There's a reason. So in Counter-Strike, there's one of the terrorist skins is the elite crew, and they wear an orange an orange vest, and they are orange because it stands out. Hence the elite crew, short for elite. And that's basically that's a mechanic that derives from aesthetics, and it has an effect on the dynamics of the game. So when we talk about dynamics, it's basically aesthetics is what we're seeing, why we're playing. All right, the hook is in the aesthetics. So for Skyrim, it's a dragon hunting game. Right, that's the hook. Besides, it's also a Bethesda game, but it's also a dragon hunting game. That's the hook underneath the story. Dynamics, mechanics is like, hey, this is the crafting system, and this is the quest system, whatnot. Dynamics is how we go about doing it. Do I do one of the dynamics is I can just go off and do the Thieves Guild. Or I could do the Brotherhood quest line, or I could do the Companions, which is the Fighters Guild. How I go about playing the game, how I choose, how I play, what weapons I use, that's all in the dynamics. It's how the dynamics is how the players play. Mechanics is what they are playing, the rules. Aesthetics is, the why, the story, the hook, what they're playing, and the dynamics is how they are playing. And you affect one, you affect the other pieces. You can affect the other pieces. You make a change to a mechanic, you can affect dynamics. And then it's not always something that I'll just bring up right now. There's what's called basically things can evolve essentially. Rocket jumping is an example of this evolution. Basically, it's a dynamic of how you use the rocket mechanics. The rocket in Quake 1, the rocket pushes you around based on the damage you take. And players found that if you jump just correctly, you can get a lot of speed and a lot of height off that rocket and not die. Emergent behavior is basically what we're talking about. Another one is Grand Theft Auto is based on emergent behavior because the developers saw one day the ferociousness and the viciousness of the cops were turned up to 11 one day, and it made for an interesting game to be. Now, original Grand Theft Auto was basically there was criminal pieces and they were supposed to be police pieces, and when they found the police turned up to 11. Made a whole different game, made the game what it is. It jumped again in, the other thing, that's, the mechanics of Grand Theft Auto 1 and 2, and we know Grand Theft Auto now in the 3D realm since Grand Theft Auto 3. It's been 3D. Another emergent behavior comes from EVE Online. They added a space where they refer to as wormholes, and basically there's normal space, and then wormhole space is connected by different wormholes. And so you have to scan down wormholes, they connect to different places, and they connect to different, and that connection can change over time. Wormholes can collapse, and they can change where they go. And players figured out all that out, and they've been able to map and kind of have an idea of how wormhole space works and what's going on. They know also how what they call roll a hole basically is shove shit through as fast as possible to collapse it. So if my home base system just connected to a base system to that another system of an enemy just connected, we're rolling that hole as fast as possible so we can get rid of it. Now, what's interesting about dynamics, the wormhole space, is that wormhole space was not designed for players to live in. But yet they have, and they thrive in those spaces. And as a reward for the player base for doing that, the developers have recognized wormhole space as another viable play style. There's the big alliances that you've heard about. There are there are faction warfare. There's people who do industrial stuff. They're all different gameplay styles, and wormhole space is another one of those play game styles. So this is why we want to get across and get an idea. You are building games. You're building rules. You're building mechanics, and you need to understand what you're building before you start building it. And that's the purpose of this lecture right here. Is again, I'm gonna you should look up the MDA framework at some point and read the document as whole.
This lecture is also being recorded, right?
Yeah, it's being recorded.
Okay,
Yep.
good.
Yep.
Just wanted to double check. Because-
All right. Aesthetics, and they've gone here and they've extended, what is the different types of aesthetics? Why is your player playing? Game is drama. Game is make believe. Game is sense pleasure. Game is an obstacle course. Game is social framework. Discovery. Game is uncharted territory. Game is self-discovery. Submission. Game is as pastime. They talk about competition. We'll worry about that later on. Again, it has weaknesses, and it's like, again, we'll go look at it. When did they? When did they publish this? Why doesn't it have when it was published? That's weird. That's weird. MDA's been around for a while, but again, it's not the end all be all. But it's a good place to start and think about in terms of what we're talking about. What is important about your game? What are we trying to do with our game? Right? What are your players going to do? And who are and ultimately who are our players is another question that comes up. You'll hear about player profiles. I'm going to leave off on that for right now because I do need to get. Let's jump into the lab document again. Yeah, so the requirement, and I'm going to be basically, I want you to create 2 new projectiles. And there will be a Carpon script. So, so you're going to inherit from, there's a PW pawn class. We'll talk about what that is. But essentially, you're going to create a car class, a Carpon script. You're going to create 2 prefabs. And then you're going to basically have it fire 1 to shoot projectile. You'll have a red card and blue card to use. Place the pawn script with the Carpon script. Set player with another player controller, the PW player controller script. Extra credit, replace the Carpon with a spaceship pawn. So asteroid to space war. Movement stays on the 2D plane. Add thrust and direction, keep moving in that direction. Vertical value is reduce the value of the ship. Another way is to place the Carpon with the airplane pawns. So descent, wing, game similar. Break free of the 2D plane. So this is more if you stay with your SOP with camel. Have arcade light controls, not flight sim controls. So fire 1 thrust off, fire 2 thrust down, pitch plane up down, rotate plane left right. So there's ways to get extra credit here, just rather than just doing cars. Yeah, this is why I break it, because it's descent and wing commander. If those of you, Ace Combat, DCS Combat, X-Wing versus TIE Fighter, Star Wars Squadrons, these are all in that. You're a plane you're flying a plane or a spaceship in space or in air or whatnot. All right, so let's jump in. Here's the basic. So basically, I have downloaded the basic framework package, and I'm gonna bring this right into your project. And here is the import Unity package. So we're going to import that. In scene, do I have a sample scene? No. It's probably in PW game. Yeah. Here's the PW example. So here we go. Let's just jump into the scene. I have a block here, and then I have player 1 pawn, player 2 pawn. So there's a manager object, and right now it has the input polar script and the PW player controller script. Okay, we'll come back to these scripts just quickly one moment. But essentially, these are missing. That's interesting. I got some issues here. We'll come back to these ones. So essentially, here's the player 1 pawn. PW pawn, what's going on? controller. Let's go back to my lab one. Okay, this is why. I need to rename this player controller lab one. Come on. Player controller, lab one. There we go. Okay. Okay, so there is a player control. There was a player control script already in my project. Here we go. All right, here we go. Manager object. There we go. Here is the input polar script. We'll go over this. I'll go over this here. Right now, the player controller is grabbing whatever my pawn is. It's grabbing that right off the bat. So the player controller. This is the representative of the player. Input number, player number. Does it log state, input state info? My pawn, which is what we're going to grab. This variable will eventually go away. What will eventually come here is that you'll have a prefab to spawn in the world instead. And you'll set this up, and each player will have its own. And actually, what I'm going to do is going to create an empty. Is going to do player controller one. And I'm actually going to move the player controller to that object. And I can duplicate this. Put player number two, player number two. Player controller 2, and then my player pawn is going to be player pawn 2. So car pawn, this is the visual component of the car. Here's the player 1 pawn. Here's the player 2 pawn. Again, I have an input polar script. So let's go through. Let's start with the input polar stuff. So let's go to the project. Let's go back to, so there is common assets as you've seen before. And there's a framework folder and a PW game folder. Let's start with the framework. And so there is an actor class. AI controller, player controller. All right. So basically this comes off an info class. If we go back, info, for our purposes, basically holds some sort of information in game. Non-actor classes should inherit from here. So this is something that's in that's a system would be an info class. There is in here I've got what is called a factory function, and it's what prefab, where's the location. Where's the location? Who is the owner? The optional controller to attach. So in here, if basically I create that object, I get the actor component off. If it's an actor, I can then assign basically its new owner if it has one, and I'll return back that new actor. Hey, get its name, get its location, get its rotation, get its transform. Some log function. So it's a kitchen sink class. So let's look at actor. So actor inherits from info. And again, the info class was a model behavior. Doesn't ignore damage of the log. So one of the big things about this actor class is that it can take damage. I've implemented a take damage function. who's causing the damage, how much damage it is, who's the instigator, who's controlling, so who do we credit, and there's an event info mode. There's like optional description of damage via event info class. Now, one of the things we've done here is that I've got basically event info equal null, which is an automatic default value. And same thing with instigator. So if the world is causing damage, this is going to be null. And if I don't care about what the damage is doing, then I'm going to set this to be null. If this ends up being null, I actually create a new damage event info just for the sake of having it, and I pass that information down. I have a process damage. And this is where damage is processed and applied, called by take damage. She only burned by children actor classes. Does damage event login. So I haven't implemented out how damage is being done, whether something has health or not. I don't care. I just, at this actor level, I want to say that I have things can take damage, and I can process that damage. Now it's protected. That means the children classes can override it and be used by the children classes. So when this gets called by that class, so this is going to be called by its class. The idea is that I'm not going to call out the damage. Process damage is not called by an external class. It's kept. This is keeping the system internal here. And again, this is an example like Unreal where process damage is done at the actor level. So if I have a wall that I can blow up, it's an actor. If I have a pawn, it's an actor. If I can do anything with it, it's an actor. Get rid of these classes. Let's jump back. All right. So the first, like Unreal, pawn inherits from actor. And it has a boolean for is it a spectator. And we have a protected variable here of a controller. Who is in charge of this object? And we can always get that, we can get that through, I've made a property to get that from. We can also get it through a function, a getter function, essentially get controller. Become controlled by. We can give it, hey, this object becomes controlled by, who's my controller? Become released. So this is to become uncontrolled, essentially. So this is, it calls, you know, and we look through here, it sets that, the controller to that object, sets its owner to that object. Uncontrolled gets, and then there's, this is interesting. Yeah, we can do things when an object gets controlled, we can do things. There's a function for us to, it's being called here, we can override it in the children. Down below, there's a here so we can do on release, and then we can set this to null. Sometimes this is weird, so we force release, so we call on release, and then we get the controller, and we set these to null and return back who was the previous controller. And you can see on control, on release. So these are functions to be taken over by the other classes, like children classes, to override and do what we want with them at times. Framework HUD basically is the basic HUD class like we would have with Unreal Engine. It's the equivalent to HUD class. Here's the basic event damage info. Basic damage. So let's take a look at the last two things that we look is input data. All right. Mirrors the Unity gamepad structure. So basically took all the variables that you would get from the gamepad, and I've made variables here so that we're not asking is released, was released. And basically I've got a clean data structure. So this is basically when I need a data structure that's clean, that's, you know, no input, I'll call this function. Now I will note that this is static. So this is a function attached to the class itself and not to any particular instance. What it does is it creates a new instance of the class, and that's what the new does, is creating a structure, and it returns it back after we set it as we see fit. And you see that I will create instances of the input data using the clean data struct function. All right. So let's go to the input puller, and this is where one of the first things that we're doing right now is we are going to break apart. Basically, all the input polling is not in our controller class. So that's one of the things that a lot of you, like one of the things we're doing is we're going to break that, gathering the input, we're going to put it in its own class. And we'll come back and we'll look at the player controller in one moment. But here's awake. And it's just basically creating, a singleton object. And it's setting don't destroy on load. This we can take out. Use this as we need be. We probably would want to put this on an object that is not destroy on load and it has that script by itself. So, but here is get input. Here's what the player number. Give it a player number and it goes to the particular functions. And we are using, yes, we're using the input system already, so that's good. So here is basically get all the gamepad values. And in this case, it was press this frame, was press this frame, was press this frame, read value on the trigger. D-pad and left stick is read value. So we're doing was pressed. Now, you may need is pressed in here. And this is I've given you the code. You can go in here and alter the code as you see fit. This is the one big thing. Like if there's something wrong, you can come and look at the code and see what's going on. So right now it's set up with WSAD, Q, D, E, Z, and Z and C as the keys. And this is IJKL, UO, and P. So there's nothing here. But you can see I get a clean struct, I get the keyboard, and basically I get the current, and I'm basically asking, is that key pressed? I'm saying left stick, right stick. I'm doing this all on the left stick. Huh. You might break this between left stick, right stick, rather than I and J, rather than left stick. I'm actually I'm going to do right stick. And I'll do this up here as well. So that I'm breaking forward and back and the rotation on the two joysticks. So let's take a look at the player controller. All right. So on start, basically it calls base start because it inherits from controller. But on update, it gets input, it processes input, and assigns the previous input to previous. So here we have reference to the input puller. So on begin, we get that. If not, there's no input puller seen. So it'll start yell that it can't do its job. Current and previous. So basically each time get input. Where's get input? So current input is the input puller.self get input player number. I don't know why I need this. I think that's why, yeah. Don't actually use that variable. Here we go. So this will crash if there's no input puller in the scene now. So that's the one. That's what I was doing. But I was doing some error checking, but I don't actually need it. But basically, there is go through here. There's get input, and then here's a process input. We're expecting to inherit from another class to do what we want. I've set up horizontal, vertical, fire 1, fire 2, fire 3, fire 4 functions. I've set them up here so I don't have to these are common functions that I would want. And they're here so to be overridden in children classes. But I can just use a player controller and just grab that and call that function from here. If we look at pawn, yeah. So there we go. I didn't save it. That's why. All right. So those are the framework classes. So typically you're not going to be going into here. There is a folder called PW Game, and this is the example. Here are your prefabs. So I've got, that's a material. So I've got basically these materials are using common assets, except for I think the bumper on the car, I think is his own material. But car pawn 2, projectile 1, projectile 2, spin projectile. So the idea is that you're going to have a root game object, and that's going to have its script, and then based on that, you'll have other, based on that, there'll be a model attached to that game object, like how the car, player 1 pawn, the car pawn here, player 2 pawn, car pawn 2 is set up here as well. All right. So look at the classes in here. So there's 3 in here. There is PW player controller, which is what's on here. This is doing the actual work. PW pawn, you can see horizontal, vertical, fire 1, fire 2, fire 3. So we've implemented all of that. Basically, the player controller is basically doing, here is input current button north, fire 1, and I'm just passing it along because those fire functions, we've been taking those booleans. But I could go, literally go and fire 2, fire 3, fire 4, button east, button south, and pass that to fire 3, and then fire 4, button west. So I've just implemented all of those buttons right here. And for the most part, basically, it's like, hey, get the pawn, what is our control pawn, cast that to our PW pawn. If that's cast correctly, then call the horizontal on the pawn, the PW pawn. That's pretty much what's going on here for the most part. I do actually need to go in and grab these. All right. So this needs to be fire 2, PC fire 2, fire 2. And you see there's a lot of duplicated code. And this is, this is your backbone of doing things. The idea here is that a lot of this code here is essentially, you'll hear about the razor blade and the handle. A lot of this code here is the handle. And again, what you're going to do in this class is basically, let's go back. Here's PW pawn. Here we actually start, starting health is here. Horizontal, vertical, fire 1, fire 2, fire 3, fire 4 are all here. So they're here to be overridden in your classes. Something I'll probably do here would be, look at pawn. Does that have a start? Actor have start. Let's just check. No. So one of the things what I haven't done is implemented a start function in these. So again, what we're asking you to do is to start with a new class. It'll be the car pawn. And all you need to do, basically, we'll start with car pawn, and instead of being model behavior, it'll be PW pawn. So so here, this we know we'll have a rigid body, RB. We'll implement public float. We'll do move speed. Public float. Here we'll actually have a start. So RB is equal to get. I'll do Quebec component parent. Rigid body. Don't need to do an update function. I don't think there's anything we need to use update for this class at the moment. But we will want to public use override, and we'll do horizontal public override vertical. We'll actually do these in the opposite order. So literally this is move forward, backwards. For sake of argument right now, we're actually not going to call the base. But basically what we're going to do is we'll say is that in RB, linear velocity is going to be used to game object transform dot forward times value. We'll just use the value as is right now. Later on, we could write code that where like if backwards goes lower. If that value is negative, then we would want to have it or third it, by a value. We're not going to worry about that right now. Horizontal is going to be easy. This is, again, we're just going to not even worry about the horizontal. This is going to be game object transform. This is going to be the transform dot rotate vector 3 dot up times value, and this is we do need the time dot delta time. And that right there is what we need to get the car up and running in terms of moving. Let's go jump in. I'll press play. And what I needed to do in the car pawn, I still got the PW pawn script. Let's remove these and put the car pawn script in here instead. There we go. And I have the cars. What's going on? So let's take a look at what's going on. Okay, so first things first, the car pawn is rotated the wrong way. Oh, negative 90. There we go. And we'll do this for this as well. So so let's go back to the pawn itself. Z is 2, we'll do X is 2, do X is 3, and then we'll move this up 2. We'll just put that 2, there we go. So So what's going on? I need to go to the rigid body. And I probably didn't do any constraints. No, I do have constraints. Use gravity, automate tensor. Take a look at these. There's always something weird's happening. On. Wow, let's crank this up to 100. That is slow. Why is that? Oh, it's value times, oh my god, move speed. That's why it's slow. Okay, why is the game object? That is what we want. Oh, this is also we forgot to do times rotation speed. Oops. There we go. Let's take a look at, let's go to the input polar. Oh, okay, these are all was pressed frame. We want to go in here and make these is pressed. There we go. No, wait a second. Oh, I know what I've done wrong. Let's go to, which class has it? Is it player controller? Process input, no. So it'd be the PW player controller. Here we go. So I changed the vertical is still correct, but this is, I changed this to right stick. There we go. So follow, again, things that you again, code can get complicated quickly. And there we go. And then you can see the other car. You can see them in action right now. All right, so we got the car up and running. The next step is basically creating a projectile. We'll just create an empty game object here. Create an empty. This is going to be projectile. Projectile prefab 1. Let's go back to my prefabs, and again, I'm just going to put the prefab right there, and I'm going to put this at 0, 0, 0, so that and in here we'll want to set this 0, 0, 0 as well. So, and this is why have it set up this way, because I can go and I'll actually turn this down 0.5 so it's smaller. We'll go to this projectile. Let's bring this up. Not 1, not that way. 1 here. So we can go now back to the prefabs, the classes, and here we can just bring in the script. Damage amount, movement speed, lifetime. I'll make this 5 for right now. I'll press, let's move this over here. So you press play, and we'll see that off it went. Let's actually go in and let's scale this by 2. Nah, that's not what I want. So there's a world here. So this is where directional camera and the main camera is. Perspective. Let's make this orthographic. There you go. That will give us a better view. And off it went. So here we can go into our prefabs. And here we go, projectile prefab number 1. And all I need to do now, basically, let's go back to, I don't need you open. So here's my car pawn. So basically we're gonna make a public game object, current projectile. And we can now just do an override, a public override fire 1. And we can just do, we need the public game object spawn point, and then we can do, again, we can do the factory. What would we call it in the... So here's the factory. So what's the prefab? That's going to be current projectile location. Again, that's going to be the projectile spawn point. Transform dot location. Sorry, position. Transform dot rotation. Again, this is not much. And then finally, the owner is basically get controller. So we're basically saying, hey, this car is going to fire this, and then we're going to use the get controller function to get our controller and pass it along to this factory. And it's going to just, and we don't, and while it does return the object, there's nothing we're doing with it. So we're just going to spawn it. Again, this factory function is what was our instantiate function, but we've done a little bit more to it. So this is a term that we're going to talk about. It's called a factory. And anytime you are building a complex object, and you need to do not just spawn an object, but also set things on it, you create a factory for that object. Unreal Engine has tons of these. It does this in a lot of different things. I'm going to save. We can go back. So, oh, it's yelling because let's go back to my player 1 pawn. Here's the projectile, and we open up the car pawn. Here's the projectile spawn point. We'll go to player 2, open this up. Here's the projectile spawn, and then here is projectile 1 again. Sorry. So I hadn't assigned these, that's why I was yelling about. So off we go. And why is that set up? Let's go back to our scene view. And for whatever reason, projectile spawn is not rotated correctly. So I haven't set up my object correctly is the big issue. Why is it rotated? That's weird. In local space too. Is the car not built correctly? There's always some weird things with this, but now we can press play. You can see I'm shooting now correctly there. I'm shooting correctly there. As we go on, again, basically there's the other projectile. The more interesting one, though, let's duplicate this, and we'll break the prefab. Prefab, unpack completely. We'll call this one projectile spin. Open this up. We'll take out that projectile and we'll put in this different model. And does this have... So I've got these lines going on. If we look at the projectile spin, we go in, there is the mesh itself. Each of these have these trail renderers. So it's going to give us, and I haven't done much with it. I haven't got actually a material on it, so that's why it's purple, but it'll be a purpose for our purpose. What we want to do now, so it's a projectile script. What we're going to do is we're going to go back to our classes, and we're going to create a new, and it's going to be the spin projectile. Classes, here's the spin projectile. Don't need to do anything to start. Just need to go into update and basically it's going to be public float spin rate. We'll do that 180 for right now. And this is basically, we're going to do an update. Basically is a game object dot transform dot rotate. I think it's vector 3 dot forward. I think I want to be doing it. Times spin rate times time dot delta time. Yeah, one line of code, just spin it. Again, we're inheriting from everything else we've done, and so there's not inheriting from model behavior. That's going to be from projectile. So everything that's the projectile set up for, off it goes. Yeah, and we can get rid of this prefab. Projectile spin. Actually, I'm going to do, what it needs to change this in one moment. Let's put this, oh, here we go. So basically this is in a weird spot as it is already. The spin projectile is, again, not zeroed out. There we go. Let's look at the projectiles. Yeah, there we go. So I'm going to move this over here. So we'll move that. So what I want is not to rotate this object. I want to just rotate this object. So let's just go in just quickly. Public game object. Let's do model. And then it's going to be model.transform. So rather than the game object, we just want to rotate the model. And we'll go back to the, we'll remove this script because we're going to replace it with that. And then we'll just assign the spin projectile. And we'll press play. You'll see that it will rotate as we expect. And I'm going to go back to projectile spin and give it a movement speed of 1. No, we'll do 3. Lifetime of 5. And then we'll press play. And you can see that it's got that spin rotation going on. So now that we know that it's working, we can turn up the speed. So this would be movement speed. We'll do 10. And do spin rate of 360. And we'll see that in action. And now that we've got that, we can now go back to our prefabs and bring this in. Here's the. I'm actually going to make a new folder here just for the sake of. I'm going to call this models, and I'm just going to grab all of these. Yeah, this is the spin. And I'm going to rename that spin, projectile spin prefab. I'll move this up. And so now I'm just going to go to my second car, and so under it, rather than having the first projectile, I'm going to make the spin prefab its current projectile. And I got to change the name, but we'll worry about that. You can worry about it later on. And so when that fires off, I need to figure out oh yeah, this is again, the issue is that so we're going to delete the projectile spin here. We'll go into the prefab, and we actually need to actually go in and change the size of this model. Basically, it was when it was spawning into the ground. So leave out of here, and there we go. So the goal of this first lab, again, there's a lot going on in this lab. There's a lot of things about conceptual things, abstraction, but basically I'm just showing you like the basics of like how to do this lab. Like, hey, all of this has been done for you already. There's things that you need to do. There'll be things that you'll want to look at in terms of the input polar. You know, again, I changed it to the right stick, so there's a lot of things I needed to change. The idea of this lab is to get you, and this lab can take longer, particularly because there's so much code that's been given to you that you have to go through. But this is no different with the Unreal Engine. There's been a ton of code given to you in Unreal Engine, and you were just you're basically juggling what's at you. The only difference here is that you can look at all that code directly, and it's all C# code, so it's clean code. I've shown you how to do this lab. Here's the car pond. All I need to do was to set up the rigid body. I needed to know current projectile, where's the spawn point, how fast, what's the rotation, my rigid body. I got it on the start. I set up the vertical, I set up horizontal, set up fire 1. I had the projectile all ready to go, so I just had to set that up. But I created the spin projectile. What's its spin rate? And I need to know the model of the spin. And I just did that on an update. Again, this is the applied uses of inheritance and again, you're using large object structure hierarchies. And I'm literally throwing you into the deep end of the pool. Again, we look over at player controller, PW player controller. I mean, it's implementing process input. Button north, button east, button south, button west, left stick, right stick. What is it doing? Not much. It's calling the similar function on the pawn. But here is again, here's process input. Again, go back to the player controller. I mean, it basically was getting the data. It was managing those two variables, which were current and previous data. So if you wanted to know if something was pressed this frame but wasn't last frame, that's how you can check. It manages that data for you so that you can, again, we can go in and be like, hey, current button north and previous input previous. And the other wasn't pressed. So this is if you wanted to go to the input puller and make these all is pressed. Then you could go. You have that granularity of input information to set that up. I'm throwing a lot at you. I know a lot. This has been recorded, so this is going to be one of the hard. This is one of the hard assignments in this class. So, think about. You don't necessarily. Again, I've already gone. Again, I literally have gone over. I've gone over these classes in class already. I've gone over Skyrim. Do Super Mario Brothers. Yeah, I mean, of these, give me one of these game applications, a diagram. Tetris is no bigger than what the Block Breaker game that we created. All right, think about Super Mario Brothers. Think about the how that the structure of the game, how the game flows. The thing about Super Mario Brothers is interesting is that it's actually more complicated to a certain extent than Mario because it has that overworld map that you are moving around on. Each world is its own overworld map. And then from the overworld map, you go to stages. And that's the thing that complicates Super Mario Brothers.
Super Mario Bros. Is the one with Yoshi, is it?
Yeah, Yoshi. No, this is.
Or is that?
That's Super Mario World.
Oh shoot.
But okay, so the overworld map. Sorry, the overworld map is Super Mario Bros. 3. Super Mario World implements that. Yoshi comes in as that at the super. That's the Super NES.
Because I don't remember a overworld in Super Mario.
Yeah, I got that wrong. So in the original Super Mario Brothers, there is no overworld map. It's just World 1-1, 1-2, 1-3 as you go through.
Yeah.
Super Mario Bros. 3 is where again I confused. My apologies. Super Mario Bros. 3 is where the overworld map comes into play. Super Mario World it's basically the 16-bit version of that game, polished. Extra credit if you do any other game application design. Yeah, but the idea here is that I want you to think about what is the structure of the game from when the game starts the load to all the way to it gets close. How does the player navigate through the application? Some games are more complicated than the others. Some games there's more going on than others. Why is it going on? What's that flow look like? All right, I'm going to stop recording right here and then I'll take questions.